Hi, myself Dr. K. Ashok, Associate Professor of Physics, Marri Reddy Institute of Technology and Management. Today I am going to discuss about the dielectrics, which was the third unit of applied physics. First of all, what is the dielectric material? Dielectric material is nothing but high resistivity material. What is the meaning of high resistivity? If you apply a voltage, there is no flow of charge carriers takes place. But here the storage of the charges takes place. Means internally the atomic positions will vary. Because of that, energy was stored. It has negative temperature of resistivity. What is the negative temperature here? As the temperature increases, the resistivity decreases. The another way of defining a dielectric material is nothing but a ceramic material, that is nothing but non-conducting material which holds electric charges. All insulators are not dielectrics, but all dielectrics are insulators. First of all, we will observe the differences between a dielectric material and insulating material. In dielectric material, the bonds are weakly bonded when we compare with pure insulating materials. In insulating material, covalently bonded materials, you need to supply large amount of energy to break those bonds. Here, the storage of charges takes place, where in dielectrics, whenever you apply electric field, then storage of the charges takes place. But here, the flow of the charge is obstructed, means the charges are not allowed to move. So that is about the distinguish between dielectrics and insulators. Based on the physical state, the dielectric materials are classified into three categories. Solid state dielectrics, examples are ceramics, plastic materials, glass, and mica. Liquid dielectric materials are distilled water. Distilled water won't allow electricity to pass through it. Gas dielectric materials are dry air, vacuum, and nitrogen and helium. These are the different types of dielectric materials based on physical state. So before discussing about dielectric topic, we will discuss about some of the definitions. The basic definitions is needed to understand dielectric materials properties. What is a dipole? In the name only it is there. What is the meaning of di? Two. Pole means polarity. So positive and negative. There are two types of polarities are there. One is positive polarity and another is negative polarity. Dipole. How will we define a dipole? It is the system of two equal and opposite charges separated by certain distance. You take it as the distance as 2a. So Q plus Q and minus Q, the magnitudes are same, but sign purpose they are different. Two equal and opposite charges separated by certain distance. This system is called dipole. Next, we will discuss about the dipole moment. What is the dipole moment? Dipole moment is denoted with mu. Mu is nothing but 2a into q. What is 2a here? 2a is the distance between the charges. What is the q? Q is the magnitude of the charge here. How will we define dipole moment? It is the product of charge and distance between the charges. What are the units for this? Simply, distance is measured in meters, charge is measured in coulombs. So simply, you can say coulomb meter is the unit of dipole moment. Next, we will discuss about the polarization. What is the meaning of polarization? Polarization means separation here. Suppose if you take a classroom, how will we polarize? Based on gender. All girls we will make to sit one side and all boys we will make to sit other side. So similarly, here we will have two types of the charges. One is positive charge and another is negative charge. So separation of the charges is nothing but polarization. Another way, how will we define this polarization means process of producing dipoles. The process of producing dipoles is called polarization, or separation of the charge carriers is nothing but polarization. After polarization, we will discuss with polarization vector. What is the polarization vector? Polarization vector is dipole moment per unit volume. If you consider a unit volume, how much dipole moment is there? That is nothing but polarization vector. But physical equation point of view, we will write it as P equals to N mu. This is definition purpose. We are writing dipole moment per unit volume. While writing the equation, we will write it as N is the number of dipoles, mu is the average dipole moment. Number of dipoles into average dipole moment will give you polarization vector. Till now, we discussed about the basic definitions. The first one is dipole. Dipole is nothing but system of two equal and opposite charges separated by certain distance. Next, we discussed about the dipole moment. Dipole moment is nothing but product of charge and distance between the charges. Then we discussed about the polarization, process of producing dipoles or separation of the charge carriers is nothing but polarization. Next, polarization vector. Polarization vector is nothing but dipole moment per unit volume. Electric flux. What is the electric flux? The number of electric lines of force passing perpendicularly through unit area. In the unit area, how many number of electric lines of force passing perpendicularly? Nothing but electric flux. More number of lines, more flux. Less number of lines, less flux. This is denoted by the symbol D. In air, if you consider D equals to epsilon naught E. Here epsilon naught is the permittivity of free space. Next I will discuss. Here E is the electric field intensity. The unit of electric flux is coulomb per meter square. Coulomb per meter square is nothing but electric flux units. After electric flux, we will focus on the electric susceptibility definition. Electric susceptibility is denoted by the symbol chi e. The polarization vector. What is the polarization vector? Dipole moment per unit volume. The polarization vector is proportional to D. Polarization vector is proportional to D. More electric flux, obviously more polarization. P equals to, simply here, whenever you remove equal to symbol, a proportional symbol, keep a constant. That constant is called here susceptibility, and D. D equals to, already I told you, epsilon naught E. Here our target is to define electric susceptibility. Electric susceptibility is P bar by epsilon naught E. P bar by epsilon naught. How will we define electric susceptibility? Simple. What is P bar? P bar is polarization vector. What is E? Electric field intensity. How will we define electric susceptibility? Polarization vector per unit electric field. Polarization vector per unit electric field is known as electric susceptibility. Next important concept, that is called dielectric constant. Dielectric constant is denoted with epsilon r. Epsilon r is also known as relative permittivity. What is this called? Relative permittivity. First of all, what is permittivity? Permittivity is nothing but the conducting capacitance of electric line of force in free space. Simply free space means you can call it as epsilon naught, permittivity of free space. Permittivity is simply, we can define it as conducting capacitance. If you allow one electric line of force, okay, how much charge it can carry. In free space, that is denoted with epsilon naught. In the medium, that is denoted with epsilon. Epsilon is known as permittivity of medium. Epsilon naught is the permittivity of free space. The dielectric constant or relative permittivity is nothing but epsilon by epsilon naught. It is the ratio of permittivity of medium to permittivity of free space, is nothing but relative permittivity, or else simply you can call it as dielectric constant. Dielectric constant has no units. Why? Because same quantity ratio. That's why this is unitless and dimensionless quantity. What it represent? It represent how much electric flux it can hold. If the high dielectric constant, more flux it can hold. Low dielectric constant, less flux it can hold. But this property is very important in capacitor applications. If you consider a capacitor, inside the capacitor we are using a dielectric material. That dielectric material must have high dielectric constant. If dielectric constant is high, your capacitance of the capacitor increases. Nowadays we are using everywhere in our cell phones the battery. In that battery capacitance 10,000 mAh, 5,000 mAh, how we are getting this one means because of the efficiency. That is nothing but high dielectric constant material we are using. Previously, we discussed about dielectric types based on physical state. Based on the physical state, dielectric materials are classified into three categories: solid, liquid, gas. But here, based on dipole present in it or not. What is a dipole? Dipole is nothing but positive charge, negative charge separated by a certain distance. In nature, we have polar molecules and non-polar molecules. You consider nitrogen and carbon dioxide. See, here to here exact. So that's where there is no chance of dipole. But when you consider water molecule, hydrogen edge represents the positive, oxygen edge represents the negative. Why? Oxygen is more electronegative. The electron of hydrogen also spins near the oxygen. That's the way here what happened, positive charge, negative charge separated by certain distance. Dipole. Certain materials have dipoles, certain materials possess dipoles even in the absence of the electric field. They are called polar dielectrics. Certain materials have centers of positive charges coincide with centers of negative charge. That's why there is no concept of dipole. Such type of materials are called non-polar dielectrics. But in non-polar dielectrics, centers of positive charge and centers of negative charge are coincide when no field is applied. But whenever you apply the electric field, what happen, the centers of positive charge and negative charges are displaced. See, positive and negative separated by certain distance means the dipoles are produced. In non-polar dielectrics, dipoles are induced. Dipoles are induced. In polar dielectrics, the dipoles are readily available. Let it be positive charge and negative charge, but they are randomly oriented. Net dipole moment here also 0 only. Dipole moment is 0. In polar dielectrics, because of the dipoles are readily available, but they are randomly oriented, net dipole moment is 0. In non-polar dielectrics, centers of positive charge and centers of negative charge coincide. Net dipole moment here also 0. In non-polar dielectrics, dipoles are induced due to the application of the electric field. But in case of polar dielectrics, this electric field causes reorientation of the dipoles, causes net dipole moment. That is called polarization. Those polarization techniques we will discuss further time. So polar molecules have permanent dipoles, but they are randomly oriented. Non-polar molecules have no dipoles, but when you apply the electric field, then these electric dipoles are induced. Polar dielectrics polarization is temperature dependent. Randomly oriented dipoles in polar dielectrics, when you apply the electric field, they try to systematically align. Again, if you increase the temperature, they become same scenario. Means polarized to non-polarized. So the polarization of polar dielectrics are dependent on temperature. But in case of non-polar dielectrics, the polarization is independent of temperature. This is about the different types of dielectric materials based on dipoles present or not, permanent dipoles present or not. These are the references I used.